Fourier transform infrared spectroscopy, also known as FTIR analysis or FTIR spectroscopy, is an analytical technique used to identify organic, polymeric, and in some cases inorganic material. The FTIR analysis method uses infrared light to scan test samples and observe chemical properties. How does FTIR work? The FTIR instrument sends infrared radiation of about 10,000 cm-1 to 100 cm-1 through a sample, with some radiation absorbed and some passed through. The absorbed radiation is converted into rotational or vibrational energy by the sample molecules. The resulting signal at the detector presents as a spectrum, typically from 4000 cm-1 to 400 cm-1, representing a molecular fingerprint of the sample. Each molecule or chemical structure will produce a unique spectral fingerprint, making FTIR analysis is a great tool for chemical identification.
Sampling process in FTIR spectroscopy involves several critical steps to ensure correct and reliable result. First is technique. Use transmission, attenuate total reflectance, ATR, diffuse and specular reflectance based on the sample characteristics. Second is collection. Gather healthy leaf sample from the lower canopy in summer to avoid disease interference. Third is preservation. Place first sample in plastic bag and refrigerate at 10 degrees to maintain integrity. Fourth is variable control. Control collection time, leaf health and storage condition for reproducible and incorrect spectra. 5 is handling. Avoid freezing and to preserve the natural state of leaf for accurate analysis. 6 is rigorous preservation. Maintain sample integrity throughout the regression technique for high quality reproducible data. 7 is significance. Proper sampling encourages reasonable FTIR data reflecting true sample characteristics. In summary, meticulous sampling ensures high quality reliable data for inquiry FTIR spectroscopy analysis.
The sample preparation is different depending on the sample type, whether in solid, liquid, or gas phase. To test a solid sample, it must be finely ground and mixed with a potassium bromide powder (KBr). Meanwhile, a liquid sample type can directly drop the liquid sample on an IR transparent salt plate or mix the sample with the chosen solvent. Then gas sample types require special gas cell with IR transparent window. The sample that we choose as a sample, example are tropical trees, which are fresh leaf (FL), instead oven dried leaf (DL), and heat dried ground leaf using a mill (GL), which is salt sample. The sample then need to dry up for few hours. Then the sample are pulverized into a small piece with IKA11 together. During the operation, the surface of the clamp and crystal surface must be cleaned up using ethanol for each of use before changing to another different sample. Make sure the sample cover up the whole surface of the crystal at the sample base when applying the sample. The sample need to pulverize so that the FTIR machine could analyze the sample better and produce a consistent wave number from the result.
Fourier transform infrared (FTIR) spectroscopy is a key tool in chemistry, biology, and environmental science for identifying and measuring chemicals in samples. It works by passing infrared light through a sample. Different chemicals absorb different wavelengths of this light, causing unique vibrations that create a specific pattern or spectrum. This spectrum tells us about the sample's molecular structure and the chemical present. FTIR is versatile and can analyze solids, liquids, and gases with little preparations. It's non-destructive, so samples remain intact for further study. Practical uses of FTIR including identifying unknown substances, checking product quality, evaluating pollutants, and studying biochemical processes. For example, in pharmaceuticals, it ensures purity; in environmental science, it detects pollutants; and in material science, it helps develop new materials. FTIR's ability to provide detailed molecular information makes it a valuable tool in many fields.
Next, Data and result analysis. FTIR analysis involves several steps to interpret results. The spectrum is observed, showing absorber and wave number. Peak identification is done by classifying peaks into functional groups based on their absorption band. Intensity and shape analysis is done to determine the concentration and possible interaction. Baseline correction ensure accurate peak location and height. Comparative analysis verify peak assignment and identify extra feature by comparing the sample spectrum to reference spectra. Quantitative analysis integrate peak regions to calculate the concentration of functional group. Data interpretation evaluates the presence and relative abundance of various functional group or compound in the sample. A clear labeled and annotated presentation of the data is made discussing the sample composition, purity, and structural feature. FTIR analysis has advantage and disadvantage, such as analyzing non-transparent sample like liquid or solid, transparent sample like infrared light, and difficult to analyze sample like inorganic materials or intense fluorescence. Infrared microscopy offers spatial resolvers measurement for biological tissues and blend for polymers. The infrared spectrum represented by a observable band is a crucial tool for identifying functional group in molecule. Small functional group like CH2OH and CO exhibit high group frequency, often visible above 1,500 cm per 1 in the infrared spectrum. These bands are unique to a given functional group and provide a reliable method to identify them. Identification wavelength reveals the entire molecule's internal process, but observers below 1,501 are less reliable. The paper FTRI plastic a Fourier transform infrared spectroscopy dataset for the 6 most prevalent industrial plastic polymers present a large dataset of these polymers using FTIR spectroscopy. This comprehensive spectrum data is useful for researchers and business people interested in understanding the spectral characteristic and chemical makeup of these common plastic materials. The analysis of absorption band and functional group in each polymer make it easier to identify and use them in the industrial process.
In Fourier transform infrared spectroscopy FTIR, which is a quantitative technique, a spectrum data is mapped to an object and molecules' vibration can be analyzed. FTIR analysis can be performed quantitatively and its absorbance or transmittance is used on different types of samples such as powder, solids, thin film, and liquids. To perform FTIR analysis, this sample is usually placed between KBR or a thin film or under attenuated total reflectance. Before analysis, a background spectrum is obtained to subtract it from the final spectrum obtained. The analysis is performed in 10-point attenuated total reflectance mode using the spectrometer, which collect the data. FTIR analysis is useful in identifying material based on their spectral properties, and libraries of known spectra are used to determine what material a sample represents.